I've been going about that.
You're good.
You ain't gonna break it. I saw a couple people fly in.
I don't know, man. I can do it.
Who else with him? Anyone else need another hand out?
We got you one.
Yeah, everyone already.
Yeah, we already got one.
See, they think they're looking out for you.
We would hope you would do the same for us. Probably not, but you know.
Probably not.
Probably not. Come on, man. The classes at one time, stop 10 minutes later.
That was right on time. You needed that, huh?
They added these in.
Yeah, I just added a couple of extra slides in. I've got to go in between two classes, so this is like the advanced semester. So everyone here takes Souls 3000, and then like in the spring, all the people who like Ag Ed, Ag Com, Ag Business, that like don't need the extra like chemical side of it, they take a kind of a more general overview of that.
Yeah.
So this is the 4-hour class, and theirs is the 3-hour. So I got two different notes, and the books are set up different. And I got old slides from there, new slides from here. It's just like, all right. I like this setup better. So we kind of left off here with talking about the different soil orders and those formative elements, and some of these major characteristics that just kind of describe some of the basics of these soils. Probably going to be something like a matching on the exam, and you'll get to do this on the quiz. And the quizzes and the exams are going to pretty much match up with them. So if you do well on the quiz, I'll open that up. You should do well on the exam. All right. You're gonna have to like write down everything on here. No, but you need to be able to differentiate between which one is which and which one isn't. Everyone got this for the most part? Anybody still need it?
Okay.
All right, so for the coming up, the quiz 1 is available right after this class. It'll be available at 12. It's due by Wednesday at 9. You've gotten everything you need up until this point to complete quiz 1. And you've really almost got everything you need up until this point to complete quiz 2. Again, this is the advanced section, and so y'all are killing it here, and we're moving through this material pretty quickly. In lab on Wednesday, if we have lab on Wednesday, don't wear white. I will probably wear white because I don't take my own advice. I would advise y'all not to wear white. We're gonna get our hands dirty. We're gonna actually be playing in soil, okay? No math. I knew I'd get someone that was happy about the math night. Most of us are aware we got some bad weather coming our way. Again, this is all kind of up in the air. I guess just look for announcements and alerts. As soon as I know something, I'll let y'all know something. And then next week, quiz 2 is going to be due next Wednesday, and then next Friday, calculation 1 is due. These dates might shift a little bit because we're almost done. And I'm not sure if we're going to move the exam back or not. That's one of those, everyone has to agree to it. And I think as we get closer to that, we'll discuss it. If not, it's going to be on the 15th. We chewed through this material really quickly, which is a good thing because if we get through it quickly, we can end quickly, end of the semester. Also, if we take exams early, you know, all the professors sat down with a calendar and said, these many classes, and y'all all have exams. You got like 5 exams in a week, or in the same 2 weeks. I'm of the inclination that if we back up 1 week, that's 1 less class that you have to take. And then that also offsets the rest of the exams for the rest of the semester. So like think about that as well, that if we move back a week for this exam, all the rest of them will be kind of moved back a week or adjusted that might not coincide with your other 16 exams you'll be taking in the, right? So something to think about. All right, What is the soil order, even though I gave these out? What about this can haplogyaults? What soil order did this come from? From the formative elements. It's not going to be on the new one. It's going to be on the old one. From the formative element, what soil order? Where do we find our little formative element? It is an altisol. Right here with this ULT gives me an indication that it's an altisol. This is going to be like a test question. I'm going to ask you to tell me which soil order this alphabet is. Okay. What about this alorthods? What soil order is an alorthod? I even put it in there. I didn't get a chance to take it out. It's a spodosol. This OD, that OD right there is what tells me that that's a spodosol. A eutrodox. It's typically on the very end of these. In fact, it's on the end of every one of them. These last little, typically it'll be ODS or ULTS, but here it's eutrodox. So this is an oxisol. Okay? This is a mollisol. This OLLS. And so that's in that. That's in these formative elements right here. All right, so there's just quick little indications that some soil scientist, we're going to go to Web Soil Survey today, we're going to look at a soil, and we can go, I automatically know that that's an oxisol. And they're probably highly weathered, where we at? Highly weathered, low base saturation, probably an old soil. Where was my Georgia person? Someone was from Georgia. Not here today. Anyhow, those red clay soils, they're just highly weathered. So these little formative elements tell me a little bit about the soil before I ever even get there. And so then we also went over this, now this actually is in this handout. We know that like this RG zerols. So this RG tells me that it's an argillic horizon. And this goes back to probably slide 4 of this section. It tells me that there's an argillic horizon, there's a clay accumulation. This XER tells me right here on this new one that I handed you out that it's formed under a Mediterranean climate. So this tells me that this is a mollisol formed under a Mediterranean climate with a clay accumulation. So that's kind of how we determine on what this soil type is. How many of y'all think you'll ever use this again? Maybe one. Maybe one, right? So like we're not going to spend a whole lot of time like trying to figure out what each one of these is. Now if you take soil classification, this stuff would apply. So we'll take a look at each one of these soil orders just to kind of give you an idea. An entisol, we know that it's a young soil. This is from that large table that we filled out. And it's an ochric horizon, which means it has low organic matter. Takes about 16% of the world's soils are entisols. So like most of the world's soils are very young and undeveloped. They're starting to, they're in the process, moving towards developing those horizons. And you can see this is largely across much of the United States, in pockets here and there, depending on climate, other things. Everyone good? I don't think there's too much to be filling in here. And so then we can see what type of subsurface horizon it is and all these other things. Next we have inceptisols, and so these are beginning to form a B horizon. Here we have the A, and then we're starting to have a B horizon. And if you notice, our subsurface horizons look at this white. Can y'all see the white in the soil? Kind of like your ball cap in the summertime. If you sweat a whole lot, those salts are left there after that water or sweat evaporates. The salts are left over from that. And look, within each one of those, just to give you an idea of how we would classify some of those soils as an insectisol, this goes back to our soil moisture regime. This one is actually climate. So wet, cryo meaning cold, eudic meaning humid, eustic kind of in between, or xeric. And so each one of those little 3 letters gives us something to identify that soil with. Andisols, going to be in Hawaii, Alaska, and kind of up in the northwest. You notice that it says a young soil, only 10,000 years old.
So yeah.
Next we have gelisols. Alaska, because cold. Again, remember I mentioned it's only warm for about a week and a half up there. I don't know how long it is, maybe it's 2 months, I don't know. But there's not enough time for any crops to grow that are going to move that soil because it's frozen all the time. It's like trying to churn ice. So they're going to be permafrost. They don't have any surface or subsurface horizons because they'll never get any weathering. There's no mineralization of anything. There's no movement. There's no water infiltration. There's nothing going on in these soils because they're frozen all the time. Our histosols, this is where we come into, there were a few things on that crossword puzzle that weren't necessarily very forthright in the reading. And that was the fibric, the sapric, and the hemic. And that goes into how those plant materials, their stages of development. So for fibric, the fibers are, we can see those. For hemic, they're partly decomposed, and then sapric, they're fully decomposed. You cannot tell the difference between the twig or the leaf. Right? So just a couple of different ways that we can classify and organize those things so we can go separation, kind of like freshman, sophomore, junior, senior. Next we have iridosols, and this is where we get those diagnostic surface horizons with calcic, gypsic, and salic. Calcic, gypsic, salic. So there's just a couple of those things, and it just depends on the climate, really, on what type of material is left in those horizons. So these are formed under low moisture. They'll have either clay or low organic matter. We have a subsurface horizon, kind of low to moderate. So this is going to be like in Arizona, out in the Midwest. I mean, out in the western part of the United States. We just don't have a lot of rainfall. Next, we have mollisols, and remember I mentioned that this is look at how much of the United States is mollisols. This is all the Great Plains area. Remember I talked about they have those natural fires. There's a lot of weather that comes across. We have that rainfall coming over the mountains when it starts to come across Oklahoma, Nebraska, and so there's just a natural progression. There's a quick cycling of that plant material, and so that's why those soils are deep. They have high base saturation, and they have several different subsurface horizons. And this is also kind of what we call the breadbasket of the United States, right? Where we grow most of our wheat. We grow corn and soybean out there as well. And as we start to move further east, we're also being productive that way. So fertility is really high because we've got a lot of our plant essential nutrients there. Everyone good? Alpha sols. Now as we start to move east, you can see in Tennessee, kind of moving up to the Mississippi and then going into what they call the Midwest. I don't know why they call it the Midwest. I do not consider Ohio to be west, but whichever. Anyhow, we're starting to get into our other productive soils. A little bit less base saturation because we've got a lot more rainfall. So as we start to move east, we pick up more rainfall, and there's also some industrialization, and that acid rain is going to neutralize some of these bases. So just a little bit lower base saturation, but still productive. And then of course we have a couple of things that we can identify. Altisols is going to be kind of, looks like it's middle to East Tennessee and most of the deep southeast, Alabama, Georgia, moving up into North Carolina and kind of going up the East Coast. There's a lot of weathering going on there. It's hot in Georgia, it's hot in Tennessee, it's hot in Mississippi, Alabama, Georgia. So we have low to moderate fertility. Our horizon, everything's leached out of here. It's all been weathered. There's nothing left. And so in these soils, altisols and oxasols, you're going to have to apply a lot of material back in order to get those productive. So knowing what soil type is also going to influence how you manage that land. And the thing is y'all are going to get somewhere, and they're going to expect you to be able to manage that land. And you're going to go, I have no clue about this. And you're going to remember back to soils class and go, Natras showed me Web Soil Survey, and I can find out something about this land so I don't look like an idiot in front of my boss. So that's where this is going to apply. And by knowing that we have an altisol, I can properly adjust for my nutrient management in those systems. As that's kind of where the application of this is. Not necessarily that you're going to be running around going, there's an Arctic horizon in there. Your boss doesn't care. How much money is that going to cost me? What's the budget going to look like? I mean, I don't know. And so I'll show you a Web Soil Survey today that there are ways that you can at least get a very quick direction and know a lot about a little. Our spodosols, we see these are going to be up in like Maine, the upper part of peninsula of Michigan, and then down in Florida. Acidic and sandy soils, fertility is low because you can't keep nutrients there. Because it's also, there's rainfall, and kind of like at the beach, when that water washes up on the shore, it just falls right through. And so there's nothing maintaining those nutrients there. And then finally, oxasols, the most highly weathered. There's no horizon, you can't tell the difference where one horizon starts and one horizon stops, because everything's been leached out all the way down. In Brazil, they have a real big problem with this because it's acidic. And so when they go to apply phosphorus or they go to apply calcium, they have a real problem with phosphorus fixation. And so they go to apply calcium to raise the pH, which we'll go over in like modules 2 and 3, to raise the pH, and it just doesn't work. And so they keep on trying to apply phosphorus to grow their crops, and it's bound to this soil. And that's real good information to know when your boss says, hey, will you tell me about this piece of land and some problems I might run into? Yes, it's an oxasol. You're going to dump tons of lime and tons of phosphorus, and you're going to get no result. Don't do that. They might do it anyway, but you can also say, I told you so. Like I did mention this was a problem. So having a little bit of knowledge about that is what they're going to be hiring you for. And then finally our vertisols. And look, this is going right with the Mississippi River. So everything coming down from Minnesota, you get all this soil from here. Those clay minerals are all being washed with the Mississippi all the way down to Louisiana. Did anybody read or hear that the storm that came through actually reversed the flow of the Mississippi River? Anybody here? No? Reversed the flow of the Mississippi River. So if y'all remember from maybe 2 or 3 lectures ago when I talked about everything coming down the Mississippi, and then hitting that Gulf of Mexico and then kind of settling down. Well, think about everything still coming down the Mississippi, and you have this storm that is pushing everything back up the Mississippi. Where does it go? Over the banks, right? So now we got this flooding going this way, right here. And so all of the minerals and the nutrients and all that stuff are settling out that way, and that's what happens in the Delta. So we have these shrink swell clays, we have a lot of clay material. I explained to you about the cracks. That's what it can look like, the cannon Hayden.
Mm-hmm. Yep.
What are you growing in there?
No.
Nothing. So what are you building on there?
Cracks.
Nothing. So like, for those of you who might be in some sort of engineer capacity or wanting to build something, not the soil to do that on. Using Web Soil Survey, you'll know this isn't the piece of land that I want to buy to build a house or a housing development of some sort. Alright, so this is where we picked up on this other part that I brought in. Again, not that you need to know all of these, unless you're going into soil classification, doesn't matter. If you asked me one of these, I couldn't tell you. It just doesn't apply to me. I'm an agronomist. I'm trying to grow crops. I'm not running around telling farmers that it's a paleoudon. They don't care. How much fertilizer do I need to apply? How come my crop isn't growing? That's what we're in this class for, is figure out how to manage land. But there are these things that you can look up online if you really needed to know, and this is how they kind of classify those, and they put each one of these little 3-letter segments together to form this Baxter Silty or Charty Silt Loam. It's a fine mixed siliceous, typic paleoudon. What the hell's what? Huh? What? Really? But that's where they get those from. So each one of these things means something to someone. Don't worry, there's a soil scientist somewhere that would turn them to just be angry with me if I were to say what I just said to y'all. But it just doesn't apply to us. But to them, it's their life. And they love this stuff, and that's cool. I'll let them be what they want to be. I just added this in. We went over this earlier, and it kind of made sense, but this is where this would now go. We had these temperature regimes, and so it's not always the moisture regime that we see in the name. It might be the temperature regime. But this is where they get that, and this is how they classify. Then we have these grade groups, and each one of these little 3 or 4 letter things gives us kind of an idea about what it is. Not that you'll need to know these on an exam, right? Typically, you just need to know the 12 soil orders and the formative elements. We went through these also. I also updated these notes online. I also updated those inside of iLearn. And then we have the family. And so this gives us some idea about the particle size, a little bit about the mineralogy, the cation exchange capacity, and then it just keeps on going on. We have temperature and whatnot. This can kind of play a role, like typically when I write my scientific articles, they like to see all this because there's someone out there who loves this stuff. They want to know. But when I write it in the article though, oh, slow down. So this just happens to be what an agronomist might talk with another agronomist. It's a Baxter Charty Silt Loam. When I write this in the article though, someone in Maine who is reviewing my article knows something about this soil. based on the family, the grade group, and then finally the soil order. Each one of those little things in there, they can instantly know something about that. So the family is fine mixed, semi-active mesic. And we get that from right here. Some combination of these that tell me a little bit about what the particle size is, and mostly about the mineralogy and how active the CEC is. So it's fine, the real fine soil, and mixed. Semi-active, mesic. Next we have the subgroup, typic, which means typical, because we couldn't figure out anything else to call it other than it's typical. That's not always the case. And then next we have a grade group. And so we get the suborder being a Udalph, and the order being the Alphasol. And this Paley means old development under humid climates, and it's an Alphasol. So if you had to, that's how you would go back and try and find out what that actually meant. All right, we're going to go to Web Soil Survey and figure out how in the world am I supposed to find those things. I guess Wednesday we'll go over like the actual, this is like leading into assignment 2, which Ms. Hannah's already done, so it'll be refracted through. We did this in soil and water, where we went into soil survey and drew the polygon and everything. Right. For Wednesday, the way to complete this polygon is to double click. And this is going to give me a soil map of all the different soils that are in here. Look how they're distributed across this. It's not just one soil type. This is even with the microclimates and the way that parent material settled there, and the way that soil formed over time. And so remember I said about those epipedons? They took one soil sample, X feet deep, and then they kept going, and then they finally hit a different type of soil sample. That's where these lines are. So back in the day when they didn't have anything else to do, this was someone's job for 8 hours a day and classifying that, long before computers. And so, we don't have a Baxter in here. Let's say we have a Bewleyville silt loam. So this gives me everything that I want to know about the different types of Bewleyville silt loam there are. And I got these for the 19,000 different soil series that we have across this entire country. I mean, so think about the time that it took to actually classify this. Y'all, it used to be in a book about like this, if you've seen them in the lab down there. Had a big stack of old books, and that's how they used to have to do that. We actually have this now online, and we can find out anything about any soil that we want. So when we go to this, we can come into Soil Data Explorer. Let's see if we can put a fairway anywhere. And we're gonna go over this again. So it tells me that where it's red, you might run into some problems trying to put a golf fairway through there. Where it's yellow, you can do it, not recommended. You might run into a little bit of trouble. We wanted to put in a motorcycle trail of some sort. Trying to find something that would actually be good there. We can also find that soil classification rating inside of Web Soil Survey. So if you just happen to know what it is, you can go to the OSDS, type that in and find out about it. Or when you're looking at it actually on the map for this whole entire section, it tells us exactly what it is. And most of them are going to be ultrasols. In fact, all of them are. Well, we got a Utra depth right here. Another one. Most of them look like they're ultrasols. Find anything listed. So it's not good for too much. That little area is not good for too much. But like you could even go look at your house or somewhere in your city, in your farm, in your area. How many people hunt? And y'all want to buy a property, right? And we're like, hey, we want to buy this piece of land so we can hunt on it. What's it look like? I don't know, Dad. Man, I'm not buying it until you tell me something about it. Web Soil Survey, you can find out if it's good. There we go. Well, that's probably not going to be good for that. There we go. Right? Green means it's okay to do this. And what I looked up was for potential for seedling mortality. So we want to go out and plant soybean or whatever it is, whatever that we're going to plant, and we can see how much the yield is going to be. We can figure out if it's going to drain well, where the low spots are, where it's going to flood. If there's wooded areas where we can cut down trees, where we might be able to grow trees. You can get this piece of land and you can start to know about it before you go to purchase it. Because there's nothing worse than buying a piece of land and then realizing it's a piece of crap. Right? And you're like, oh man, now what am I supposed to do with this? Now I got to try and resell it out, you know what I mean? So there's several different applications for this, and we'll get to work on that in Module 3. But in Module 2, for Assignment 2, we're just going to get familiar with this type of software working through that. I've had more students come back and tell me, man, I'm so glad you taught me how to do this. So this is actually going to be applicable to you. You are likely to use this in the future. As long as you can remember, you know what? Natras told me about web soil survey, and I can figure out about this piece of land. Because if Logan comes to me and says, Dr. Natras, can you help consult on this piece of land? This is where I'm going first, because I don't know where this piece of land is. Here's the GPS coordinates for it, and I go, what? So I go fly my drone over it, and I get an idea of what it looks like. I can see what timber's on there, or what isn't, or where there might be some good spots. Come back to web soil survey, and I can start to develop something. I'd say, look, here's a good area for you to plant your soybean. And this is likely to be the yield that you're gonna get. Oh man, that's worth it for me. Okay, yeah, hey, we need to plant here. Don't plant there. So this is actually applicable to y'all. All right? So we'll pick up and do this on Wednesday. If you want, you can go ahead and print assignment 2, bring your laptop, and we'll work through this, okay?